last scientific event of this day. It is one of the very nice aspects of being president of ISIR that you can select a special lecture, so-called presidential address, and I had immediately the idea to select for this special lecture Professor Elsbeth from the Technical University of Zurich. That's a big difference for this lecture. She is a long-term friend and collaborator. We did several things together, some of which you might have heard or probably have heard in the morning, the research on chess that Roland Abler presented. In fact, we were, this doesn't work as I wanted. Okay, that Roland Abler presented. We also wrote together two, let's say, books for lay persons, for the general audience on intelligence. This is especially surprising as Elsbeth is an educational psychologist, and she is one of the rare educational psychologists who is interested in the fields of intelligence and who believes in the impact of intelligence. That is very rare among educational psychologists. Elsbeth started her academic career as a cognitive psychologist with a focus on academic learning in science and mathematics. Received her PhD in 1987 at the University of Hamburg, and after that she had several positions at the Max Planck Institute of Psychological Research in Munich. In 1994 she became professor of educational psychology at the University of Leipzig, and in 1997 she moved to Berlin and to the Max Planck, to the very well-known Max Planck Institute for Human Development in Berlin. Since October 2006, she is professor of research on learning and instruction at the renowned Technical University of Zurich. I mentioned that already, where she is also head of the teacher education program, and also since 2012 chair of the Department of Humanities, Social and Political Sciences. She has studying the interaction between intelligence and learning and knowledge in a large age range. You will hear about that. She did research on the use of visual spatial tools in learning, and is also editing on the editorial board of several journals. She is also on the board of Science. She is furthermore involved in many international discussions on the relations between neuroscience and learning, and how neuroscience can be used to improve learning. Yeah, Elsbeth, we are happy. That doesn't work. I don't know what's going on here. This is a different system. Better start with your presentation. I don't know how. This, okay. Yeah, this was only to show Roland Grabner, who is our, so to speak, child. The way he was oscillating between different places where Elsbeth and I were working. Okay, so my pleasure, special pleasure to have you here. We are looking forward to your comments.
Thank you very much, Alyosha, for this nice introduction and also for the invitation. It's my big pleasure to talk in this audience about education and about the relation between intelligence and schooling. And I hope that you will be informed that the gap isn't that big. Given there was really a common past, a common history, Nowadays, educational psychology and intelligence research are a little bit like estranged siblings, but I hope they will come together soon. So there are common roots, we all know of them. Intelligence tests were developed to inform educational decisions. For instance, about special education in the United Kingdom, there was Cyril Bird, very well known for developing tests which informed admission to the secondary schools, the so-called grammar schools, and the SATs were informed, which are used in the States by intelligence tests. And we shouldn't forget that intelligence tests were validated against school achievement in the early days, and there were also very well-known intelligence researchers who started as educational psychologists, as Carroll and Kohlbach and many more. So there are also some reasons for growing apart, and one of them is, of course, intelligence tests lost a little bit of their impact on educational decisions. One is because special education nowadays is practiced any longer in most countries in special schools, but it's a kind of inclusion. So there is no longer a need for intelligence tests. And also in the United Kingdom, the tripartite system was replaced by a comprehensive school system, therefore the intelligence tests are no longer necessary. There are school systems which use streaming or tracking, particularly in the German-speaking countries, in Austria, in Switzerland, and Germany, but there is no tradition of basing the decisions on intelligence tests or other standardized tests. It is more the teacher decision, but this produces interesting results which I will present at the end of my talk. So there are other reasons for both fields to grow apart, and one of course is that both fields developed a little bit different research foci. To say in a certain sense, educational psychology focuses more on the increase of means, while intelligence research is interested in the variance. And this of course led to different research questions and agendas. In education psychology, one wanted to find out what kind of teacher practice, what kind of school systems might improve achievement. And also there was a cognitive perspective on learning, which focuses more on how knowledge can be enhanced, and also other factors than intelligence, so-called cognitive factors, motivation, were investigated according to their impact on school achievement. Of course, you know better than me all the research agendas in intelligence research, which focused on the impact of genes and of the interaction between genes and environment, and also on the neural correlates of intelligence. So both fields made good progress in the last years, and there are probably good reasons to focus on different topics. But I think the time came to come together again. But there were also some serious attempts to undermine the collaboration between both fields, and they came from quite prestigious universities, from Harvard and from Stanford. To start with one, Carol Dweck, she has done good research on motivation, but how she considers intelligence really deviates from what we probably understand by intelligence. For her, it's not so much what intelligence is, but how people see intelligence, and it could be better to see it as manageable and not as fixed. And if you read the citation, if you read this, for her, genes are the same as these chronological and chronological things. So, of course, I mean, nobody would agree to this. There were also other attempts that cognitive factors aren't that important for school learning. There was the idea of emotional intelligence, which of course there are emotional competences, but we know that these competences cannot be measured to the same degree as cognitive intelligence can be measured. And Howard Gardner had very big impact on schools and on teachers with this multiple intelligence, which, as I said, talked down the importance of cognition. We know it's not true, but it's very popular. There were also other attempts which were not very fruitful for a collaboration between schools and the intelligence researchers. And this was, for instance, this book, The Bell Curve, which conveyed the message that investments in education were called into question because genes were understood more as, or genetic was understood as unalterable, and there were some misunderstandings that similar IQs means similar genes. We know, of course, that's not true because there are many people who didn't have the opportunity to develop their genes and to develop the IQ. And of course, that was also mixed with ethnic questions. There is no reason to assume that the genes that express the color of the skin and of the hair are the same, which are responsible for intelligence. So there is no reason to mix this up, but it damaged a little bit the collaboration and also the reputation of the field. Anyhow, we know it better today. I very much like this book. It's no longer nature versus nurture, but nature via nurture. It's a very nicely written book from Matt Ridley. And the question which comes along here is, what kind of nurture do genes related to intelligence need to express themselves? So it's really that you need every gene, or most of the genes, need a certain kind of nature in order to express. And when it comes to intelligence, we should ask what kind of nurture, what kind of environment is needed for genes to express. And one of my favorite sentences, I already wrote it in the abstract, is psychology now recognizes intelligence as education's most important product, as well as its most important raw material. It comes also from a person who was involved in methodology, very much Rich Snow. He passed away a little bit too early, but I also like the sentence, the psychology of human differences is fundamental to education. And I would like to focus on two things, the product and the raw material. So first, intelligence as education's product. What does it mean? It means, of course, that higher cognitive competencies, as they are measured in intelligence tests, and also in non-verbal ones, they require schooling for the genetic potential to display. Without schooling, no intelligence in the way we measure it in tests. The second is, of course, IQ stabilizes in the course of elementary school. There are many data on this. And this happens at an earlier age for the verbal IQ than for the non-verbal IQ, which somehow clearly contradicts the investment theory of intelligence, but it shows the impact of schooling on intelligence, because in the beginning of school there is a lot of verbal activity, and this helps to stabilize individual differences in their cognitive potential. And there are also many studies which show that the quantitative and qualitative aspects of school education can boost the IQ, at least by some points. For instance, the summer whole or the years of school, CC has shown them. So I think this was covered by the literature. And the next point is education as, or intelligence as education's raw material. There are correlations between IQ and school achievement. They vary between 0 and 0.77, right, 0.77. I looked up the correlation in Ian Deary's paper, which was discussed yesterday morning, and I found a correlation, or it was the reported correlations of 0.77 for mathematics and IQ, so it's really very high correlation, but I will also report data which show that there are 0 correlations. And what we know is that the correlations are higher for achievement tests than for grades, which is clear because grades are given by teachers and they are biased by many assumptions. And they are higher for mathematics than for other subjects. However, there is something more to this story. What happens when prior domain-specific knowledge comes into play? What happens to intelligence? And how does instruction alter educational outcome? And now I come to the second person who was quite similar to Dick Snow. He was a European person, Franz Weinert, unfortunately also passed away too early. He was director of the Max Planck Institute for Psychological Research in Munich. He was my academic teacher. I worked with him for many years. And I also would like to present a longitudinal study. After we saw so many longitudinal studies, he developed the study in Munich. And there were a lot of well-known people also involved in it. Some know Jens Asendorf, Andreas Helmke, Wolfgang Schneider. And the idea of this longitudinal study was really to have a comprehensive view on human development. The number of subjects is relatively low, as you see in a moment. We started with 220 children. They were born in 1980, and but it was a very dense measurement points. 3 times a year the children came to the institute, and we had a lot of measures on intelligence every year. And when the children entered schools, we tried to get the whole classes for some of the tests, so we can combine educational impact and individual development. There were follow-up tests even after Weinert's death, when kids or the young people were 25 years old and 70 years. I could, of course, tell a lot about the story, but I will focus on one field which, Jörg told it already, is my competence, and this is the development of mathematical and scientific knowledge. We tested verbal and non-verbal IQ, mathematics, achievement, reading, memory, and social indicators, all kinds of shyness, for instance. And the research question was domain general and domain-specific income on educational outcome and also on other variables. And the question was, of course, how do individuals with different cognitive abilities exploit learning opportunities provided by schools, as it's written here. So I first would tell something about intelligence and STEM learning. The question is, of course, what happens when prior domain-specific knowledge comes into play, and how does instruction alter educational outcome? And we have to become aware of the fact that there is more about academic achievement than just brain characteristics. So think about a very intelligent inhabitant of the Roman Empire, Caesar or whoever. He wouldn't be able to solve this problem just not because he is stupid or he was stupid, but because this was not in his culture. The division was not part of the culture. Today's medium gifted child, 8 or 6 or 8, could easily solve the same problem in another symbol system, just because the culture today has provided tools, symbolic tools, which can be used as reasoning tools and which can be used for developing more abstract concepts. When we want to understand the difficulties of learning science at school, we also should call it to our minds that human mind or human brain, to the best of our knowledge, was more or less developed 40,000 years ago. The genes which guide the brain development, they haven't changed much in the last 40,000 years, but of course the knowledge has changed a lot. But most of the topics which are part of the curriculum only changed some 100 years ago. For instance, the use of script just 5,000 years ago, and the use of Arabic numbers and 800 years ago. Analytic geometry, which caused a lot of difficulties, was invented 400 years ago, and so on. Laws of mechanics 300 years ago. So it's, from this perspective, it's kind of miracle that medium-gifted children can learn these things which genius minds have developed over thousands of years. But we have to consider the cultural development when we talk about achievement and about academic achievement. So from a cognitive point of view, learning, academic learning, is knowledge construction. And of course, we are all familiar with the different distinctions made in cognitive science. declarative and procedural knowledge, that means knowing why and knowing how. And declarative knowledge is composed of facts and concepts. Concepts are very important because for learning in STEM areas and other academic fields, and there are two ways to change concepts: enrichment or restructuring. Remember the example Alyosha brought to yesterday morning, that Graz is the second biggest city in Austria. Probably not everybody knew it, so you learned something new, but it was quite easy to understand because you didn't have to restructure your concepts about Austria or your concepts about city. It was just adding the new information, or probably a little bit of restructuring if you thought that Salzburg was the biggest city. But in many other fields, you have to restructure your concepts in order to understand the scientific concepts or the mathematical concepts. And the challenge in STEM learning is what we call radical conceptual restructuring or change. And this often means the shift from just some characteristic features to defining features. A simple example is what is an uncle. A little children say it's an old man, but of course that's only a characteristic feature, and the defining feature is it's a parent's brother. But this kind of shifts can cause a lot of difficulties, particularly in physics and mathematics, and I will just bring some examples. Consider just a 7-year-old child. You ask the child, does a heap of rice have weight? And the child says, yes, of course. Then you take a single rice grain, ask the same child, does this grain of rice have weight? No. So the question is, what does this child miss, you will ask. General cognitive abilities, Piaget probably would have said still not in formal operation, still not in formal operational thinker. But these are outdated interpretations. It's just the conceptual knowledge that's different in children than in adults or older children. Susan Carey had the wonderful idea to ask the child, what happens if you put the rice grain on an ant's back? Does it have weight? The child says, yes, of course, then it has weight. So the child just has a very different concept of weight. For the child, weight means an object feels heavy. For the most adults who didn't undergo physics studies, would say what you get from a scale, and the physicist says the force on the object due to gravity. So this is the same word, but very different understanding, and a lot of instruction in school goes wrong because teachers do not recognize the gap in conceptual understanding. And this causes the difficulties. I bring another example to show that children have perfect logic, but they miss just conceptual understanding. One of my colleagues told me a very nice example of his little daughter. She came home today. We learned at school that humans descend from apes. Is that true? Baba, yes. And the child, when was I an ape? So the child is perfect in logic. But of course it has a different concept of mankind. It doesn't understand human beings as a species. It thinks men are just the people she knows. So she was a baby, so why shouldn't she have been an ape? And there are these kinds of difficulties that these kinds of misunderstandings that cause the difficulties in STEM learning. There is also conceptual restructuring in mathematics. At school, we had to learn that there's more to numbers than counting. Counting is somehow based on innate resources. We know the number instinct. But at school, we have to learn about fractions, and then we learn that, you see the examples, that 6/7 is larger than 6/8, and the decimal numbers, we have to learn that not every number has a defined successor. And all these things cause difficulties. One example I will focus on is understanding the quantitative comparison. When I started to work on learning early mathematics, there was one result in the 1990s which was found all over the world, which was really striking. It was in the time when transfer was an issue. You have the words problem here. Here are 5 words and here are 3 words. suppose all the birds race over and each tries to get a worm. How many birds won't get a worm? If you present this problem to a 6-year-old child who didn't enter school yet, about 99% will solve it. But if you present the same problem with the question, how many more birds than worms are there, you only get 25 of the kids to solve the problem. So what's the discrepancy? I worked a lot on this discrepancy in the 1990s. It's not just birding. There were a lot of experiments which showed that it had nothing to do with language understanding. It's really understand, and you can find other problems where you even have a larger discrepancy. It's really the understanding of numbers, because these equalizing problems or these bird problems, they draw on a very different number understanding than how many more problems. I will show this in a minute. One can represent the number 5, for instance, as 5 objects, as you can see. Preschool children easily can do it, but you also can understand it as just a section on the number line, the relational number. And this really requires academic training. Children do not bring this kind of knowledge it doesn't develop spontaneously. It should be focused on, at school. And when I was involved in this longitudinal study I described a minute ago, I presented a lot of comparison word problems to find out how they impact later mathematical understanding. And I would like to share with you one result which shows the impact of prior knowledge compared to intelligence. It's again this logic study. I only focused here on students who went to the highest track of the German school system, the gymnasium. It's not a gymnasium, it has nothing to do with sports. It's really the highest track of the schools, and it allows access to university without any entrance tests. We had mathematical competencies in grades 2, 3 to 6, and algebra was tested when the students were 17 years old, so still at school, at least at gymnasium, and we had intelligence tests all the time, non-verbal. I wanted to find out how students' achievement was in this kind of algebra problems. They were not really appropriate for 11th graders. They usually one deals with this kind of problems when students are in grade 8 or 9, but I presented them as speed problems, so it was a solid measure of mathematical abilities. In 2nd grade I had this kind of comparison problems, and here you see a more complicated one which really requires a lot of building of mental models. In the 4th grade I had this kind of problems. You can read which also requires children, most of the children add instead of multiplying, so it also requires kind of abstract mathematical modeling. And what I wanted to find out was how these measures predict algebra learning in grade 11, and I could compare it to intelligence. These were the correlations, so I just had simple correlations. The sample size is too small for all this complicated analysis, but I think the story I want to make, correlations are enough. I also had computing, that means arithmetic tests, and here you have the intelligence tests. And you see 4 interesting correlations which show here you find achievement in 2nd grade in mathematical reasoning. That means mainly word problem solving, and a correlation of 0.58 with 11th grade achievement in mathematics, while intelligence measured at 11th grade, that means at the same time as the young people took the algebra test, had a correlation of 0.41. Of course, there is no significant differences, but it's interesting to see that this correlation is at least not lower than this one. I did also, here you see the scatter plot, and what can be seen is that children who performed poorly in grade 2 on these word problems, they had rarely a chance to catch up in mathematics later on. So early prior knowledge matters, and it matters more than intelligence as soon as you, of course, include prior knowledge. Intelligence has the impact of the acquisition of knowledge, but as soon as you have measures of knowledge, intelligence loses impact. And this can be also seen in this communality analysis. You have here this kind of diagram. This is just the impact of second grade mathematics. It's just the explaining variance, and most of the variance remains unexplained. But it's interesting that there's only a very small part of the variance explained by intelligence. If intelligence hadn't been invested earlier on in mathematics, of course this is confounded intelligence, plays an important role. But the story is you have to invest intelligence into knowledge. Learning trajectory. So the question is, more or less intelligent students differ in their kind of knowledge acquisition. I've never found evidence for this. I expect there must be some differences, but yeah, up to now nobody has ever found it. A more intelligent children make similar but fewer mistakes than less intelligent ones, and more intelligent children need less time for achieving a certain level of achievement just. But it's only time and mistakes, and there are no qualitative differences. Different trajectories have hardly ever been identified. Also, I think it's worthwhile to go on with this. I will come to this later. So the story here was that intelligence has to be invested in prior knowledge in order to predict the achievement. And I know most of the intelligence studies, they do not consider prior knowledge, and therefore find quite high correlations between intelligence and school achievement. But as soon as prior knowledge would be taken into account, the impact of intelligence goes down. So the next question is how instruction may alter just mathematical achievement. And I draw on the same data set you saw before. We know that instruction can have really a very good instruction can have an impact on students' achievement. And educational psychology also has found a lot of variables which characterize good instruction, and I will just mention some of them, and they all go back to teachers. So all political attempts to change the school system to reduce class size, they do not have any effects unless teachers change the way of teaching, and unless they really give a kind of instruction that is more meaningful to the children and so on. So it's really the teacher who makes the difference. And what makes a good teacher? Is it just a personality trait or whatever? No, we know some factors which can be learned, which should be learned in teacher education, should be learned in professional development. The kind of professional knowledge teachers need, we call pedagogical content knowledge. That means to combine the content and the knowledge about teaching. That means, for instance, being aware of students' misconceptions in the field. The misconceptions you already learned about, teachers have to know them in order to be prepared that students have them. And also supporting conceptual change by providing problems that cause productive failure, for instance, really cognitive activation of students, not just practicing all the time problems of the same kind, but really challenge students' minds to help them to build up conceptual knowledge, and also providing informative feedback. Many studies have shown that this is really an effective way of improving students' achievement. And what I want to show is that teachers who are aware of these factors and who have a kind of pedagogical content knowledge, that they really produce better learning outcomes than teachers who haven't. In this study, it was published more than 10 years ago, but it helps to understand how teachers can alter achievement gains. Again, this was the sample I relied on, and this time I relied on the sample which came from the schools. So we had a bigger sample of more than 1,000 students. What we did was we presented a questionnaire to elementary school teachers which had been developed in the United States a long time ago. We translated it into German. And the questionnaire asked about the teachers' understanding of how learning works. Whether it's more a direct transmission view, that means the teacher has to just write something on the blackboard and it directly goes into students' minds, or whether teachers have an idea of knowledge construction and they see their role more in supporting students to construct their own knowledge. So the constructive this view would be children learn math best by figuring out for themselves ways to find answers to simple word problems. The direct transmission view would be an effective teacher demonstrates the right way to do a word problem. And the teachers had to agree on a scale from 1 to 5 or disagree on these statements. There are altogether 48 items. And we found tremendous results. If we stay on the classroom level, we found a correlation of 0.50 between the teacher's degree of cognitive constructivist understanding, that not direct transmission view, but really understanding learning as concept construction, and the classroom gains. And I should say we are in a very lucky situation. We had a quasi-experimental situation because in Bavaria at this time there was a compulsory teacher change from grade 2 to 3. So we could disentangle students' prior knowledge and teachers' impact on students' knowledge. So this was a lucky situation we made use of. Therefore we got it published quite well. But I would like to present some more detailed results. The sample size was large enough to do some complicated analysis. We had mathematics achievement in grade 2. This was also word problem solving. We had the IQ in grade 3, and we had the impact on teachers' beliefs. And what we find, of course, is that individual variables always account for the biggest part of variance. But it was, in this case, it was the prior knowledge, while the impact of IQ, if it's just a prior knowledge is included, which of course covers a lot of IQ, I don't call this into question, but what I want to say is that the poor IQ, if it hasn't been transformed into prior knowledge, doesn't account for much variance. We see that the gamma of this H&M analysis for IQ was 0.16, and for the teacher's beliefs was 0.12, so it's quite similar. So another question that came up is, of course, and it always comes up, whether students, according to their abilities, also according to their intelligence, gain from different kinds of instructions. Whether poor achieving students that are overtaxed probably by a cognitive constructivist view or by other more demanding kinds of instruction. And what I should say, it has never been found. This sounds very plausible that probably there would be an interaction like this. So the poor achieving children, they gain from another kind of instruction than the high achievers. But in many studies tried to find this kind of interaction, but it has never been found. So I think it's a very good result. Yesterday evening we had a poster from my postdoc Esther Ziegler, who also looked for aptitude treatment interactions, but didn't find any. So we can conclude that just good instruction, professional instruction, helps all students, but of course according to their abilities. And the goal of schooling is not to reduce variance, but to shift just the normal distribution in the right direction. So now I come to another question: why do correlations between intelligence and educational outcome or achievement vary so tremendously. So I have found some which are 0, most of the, or many of them are 0.20, and as I said already, in ISIR's paper I found a correlation of 0.77 between IQ and achievement. And yeah, this correlation, of course, suggests that there was not much room for altering achievement by instructional quality. There could be no room. There could be 2 reasons. One is, of course, that all teachers in Scotland are alike, or at least very similar, either similar good or similar poor, we don't know, but they don't produce variance. Or it could also be the case that the measures of these tests, and I looked them up in the internet, it is a standardized test on achievement, that they allow, or the tests presented, or the topics tested, they can be acquired in different ways. In mathematics, I looked quite carefully. It were tests on proportional reasoning, on fractions, on percentage. And the test was presented when children were 16 years old. So if they had a poor or bad instruction at the age of 12 when they learned fractions, the intelligent students could have many other opportunities to learn about fractions because there are many just opportunities in everyday life or whatever. So it's really probably the case that there are some topics at school which require or are more dependent on instruction than others are. And we know that regular mathematics can be learned. Of course, it's best to be learned by a good teacher, but there are many other opportunities to learn it. And I would like to come now to my other research field, to physics, to show that there are some topics which really are dependent on good instruction. So if you may try to solve this problem, I think we all were faced with similar kinds of problems when we were in high school, when we had mechanics instruction. But the fact is that no matter how long your instruction was, the solution rates are very low because physics is one of the most difficult fields. And what is normally found that solution rates for students who had undergone a curriculum on mechanics, so who had the chance to learn about force and motion and Newton's axioms, then nonetheless the solution rates are lower than 15%. We even found it for students who enrolled at our university. The question is, of course, what is going on in these classes. It's very well known that poor physics teachers focus very much on formulas rather than on qualitative concepts. Therefore, many students fail to distinguish between impulse, force, pressure, speed, velocity, and acceleration. They learn these terms and they learn the formulas, but they don't know how to deal with it. We know, of course, formulas are important, but they should come at the end. Students first should get a kind of qualitative understanding of these concepts before they learn to deal with formulas. Teachers very often, particular physics teachers, have the wrong idea of how humans learn. They have clearly this direct transmission view. They think they have to write the definitions and the formulas on the blackboard. And if the students are intelligent enough, they just should xerox them in their mind. But of course, this is not the way to do it. And many teachers, we do a lot of studies on teachers, have little knowledge of how to provide cognitively activated learning environments. I will now come to my current research, where we try to improve achievement in physics and to better exploit the intelligence resources by improving teacher education. The study is run by Sarah Hofer. It's an ongoing study, but we already have enough results to to at least be hopeful that it, yeah, we will have really nice findings. What we know, of course, is that many otherwise competent students are spending years in physics classes without acquiring any usable knowledge that may help them to better understand the world. It's also, we could call it underachieving in physics. Sarah had been in Swiss Gymnasium in many classes. She had administered intelligence tests, I come to this later, but she found that there were students with an IQ of 135 who completely failed in physics. They had poor grades, and also in some tests which focused on conceptual understanding, they showed that they didn't have understood the most important things. At the same time, she found a correlation of 0 between intelligence and the grades in physics. It's a selected sample, but it's nonetheless interesting, and I wasn't astonished because intelligent students probably don't like rote learning of things they haven't understood, so they just gave up physics, and also was confirmed in the results. Among these were a lot of females. But what we found was that really, when we had a teacher training, and it's a quite intensive training we do with some teachers, and the teachers learn to focus on conceptual understanding, the number of underachievers was really tremendously reduced. I will leave it with this description because I want to wait for some more quantitative results, but I think we better can exploit intelligence in physics classes as we currently do. So in the last part of my presentation, I will stay with the question how intelligence and school achievement come together, and I will focus on admission. As I said in the beginning of my talk, in the German-speaking countries, we still have this tracking system. There is an academic track in Germany and in Austria. It starts at age 10, in Switzerland a little bit later. As students go to the gymnasium, and if they are successful, they can go to university after 9 years. And the decision for going to the gymnasium is not based on standardized tests, and also not on IQ tests. It's more kind of school achievement, teachers' recommendation, and so on. Therefore, the question is, if we have IQ data, are they related to this admission to the gymnasium? And in the different data sets, some of them I already introduced to you, I got data which helped me to find out whether intelligence kind of prevails or is a surefire for admission to the gymnasium. So here you have the first data set. It was from the Munich longitudinal study you are already familiar with. When the children were in grade 4, we administered an intelligence test. It was a verbal test. The decision was already made by the teacher who got a recommendation for the gymnasium and who didn't. And what you see is here is the distribution of the children who didn't get the recommendation and the distribution of the children who got the recommendation. And of course the mean was higher than this one, or other would be really crazy, but you also see a very big overlap. There were about 60% of the students you couldn't guess from the IQ whether they would go to the gymnasium or to a school which leads to vocational education. At this time, I thought, of course, there must be, and we know it, there is, of course, a big effect of social background. Parents who have a university degree, they really persuade the teacher to give their child a recommendation, while others don't. So particularly this should happen in the middle. We see an IQ of 110. The probability is similar of going to the gymnasium or of going to the vocational track. So IQ seems not to be too selective when it comes to this school system. I now have data 20 years later. These data were from the 1990s. These are not my data. I asked a colleague who ran a very big, large-scale study on reading achievement, and who also administered this little intelligence tests. I wanted to find out whether the impact of social background will only be in the middle of the IQ distribution, or whether we will also find it at the other end. That means will also children have an IQ of higher than 115, will there be the social bias? And because in the global IQ study, it was one of the first attempts in Germany to administer just a standardized test. It was here on reading. It was run by my colleague Wilfried Groß, and they made the analysis I asked them to do. They also had a questionnaire on social background, so that they could find out whether the children come from a high, from a middle, or from a low social background. So here you see the results. I presented them in a very easy way. The social background you see here, and here you see IQ under 100, IQ 100 to 115, IQ over 115. And these two probabilities are particularly interesting. For a child who comes from a high social background, the probability to go to the gymnasium is 0.50. Quite high, given that the gymnasium should be an elite school. But for a child with an IQ higher than 115, from a low social class, the probability is also 0.50. So I was a little bit shocked by this data, because it really shows that it's not the IQ, but it's really the social background which decides where the children go to. And I should say, I don't have the data here, but the decision on going to the gymnasium was made on school achievement. And what was also found, there was a test on reading achievement, that these kids weren't that good in reading as were these kids. But of course the question is what has gone wrong in school, if school isn't able to teach children with an IQ like this reading. That's something really awful wrong in the school system. So some data with Switzerland. In Switzerland it's a little bit different. In Germany and also in Austria, about half of the kids go to the gymnasium. I think even more in Austria now. But in Switzerland they don't want to more than 20% of the students to go to the gymnasium. It's a quite strict line. There's very good vocational education training, so they do a lot for all the other kids. But the question is also, of course, what are these 20%? Are these the most intelligent 20% or not? And I can use the data from Sarah Hofer, who did the study on physics education. Here is the theoretical distribution. If the most intelligent 10% would go to the gymnasium, there should be an IQ, minimum IQ of 112.6, because it's a percentile of 80. And the distribution should look like this. If the admission would be by chance, it should look like this. And here I have the real data. And what we see is the norms were a little bit outdated. So you see it's more than the maximum. The curve should be shifted a little bit in this direction. But there are also at least 30% of these students who go to the gymnasium, who get the recommendation to go to the gymnasium, but they miss by far some of them the minimum IQ. And there are, of course, also the same number of the same part of students who bring the IQ, but they don't get they don't go to the gymnasium for whatever reasons. I don't have data on social background, so I don't know, but I have a strong hypothesis that it has to do a lot with social background. So what can we learn from all this data? I now come to the conclusions. School education supports the expression of the genes which are related to intelligence. No questions. I never called into question when I saw all these twin studies that there are stable IQ differences, but at the same time IQ needs time and needs support to develop. Academic achievement results from investing intelligence into knowledge acquisition, and this has to be done in a successful way. A proper investment of intelligence into academic achievement cannot be taken for granted, but rather depends on teachers' competencies and on admission policy to higher education, and these are not always in the shape they should be. But what we also saw is that investment in teacher education and in their professional development is worthwhile for more as well as for less intelligent students. They all gain from better instruction, and this is probably the most important message. And I could end now, but I would like to, for 1 minute, to describe my ongoing study. We think that we really should work on students' knowledge in topics which are difficult to learn, for instance, physics. Therefore, I started a big longitudinal study with my colleagues on early physics education. It's called the MINT study. MINT is mathematics, informatics, natural science, and technology. This is a German abbreviation for STEM. And we train 300 teachers in instructing some topics of physics already to elementary school children. For instance, why does a large ship of iron float in water although a small piece of iron sinks? And there are other topics which helps children to develop some basic concepts of buoyancy force and of density, or they give up misconceptions, for instance, that air has a negative weight and all these things. And we hope that this kind of instruction will help all children to become better in physics learning. We already were quite successful in implementing the instruction in school, but of course we have to wait for the harvest because the children have to grow older. But a central research topic, and now I come back, is the impact of intelligence on trajectories of conceptual change. I still think there must be different ways of learning concepts for more or less intelligent students. And I have a doctoral student who is focusing on this, and this ends my story. It's Peter Edensbrunner. He was Alyosha's master student, and he joined my group as a PhD student. So I hope I convinced you that there is mutual benefit of education psychology and intelligence research.
Thank you, Elsbeth, for this wonderful talk. Inspiring, stimulating, controversial. That's how it should be. And the question is, are there any questions or ideas, or do you know of any studies showing an aptitude treatment interaction, for example? Questions? Yes.
Could you tell us a few more details about the study that found a correlation of 0 between IQ and educational achievement? That seems astonishing.
So it was just between grades in physics at the gymnasium and IQ. We found it because the students some students who really didn't understand anything about physics, but they nonetheless got good grades from the teacher because they were quite good in using formulas or in rote learning. So at least it's of course a select sample, but we've had some data which really showed that within classrooms there was no correlation between IQ and the grades.
So what sample size are we talking here?
Altogether about 200 or so. I hope it's not always the case, but in this sample we found a higher correlation between IQ and achievement tests.
Okay.
You spoke about the relationship between intelligence and admission to a gymnasium. First, I want to add that in Germany, usually not the teachers decide who is going to a gymnasium, but the parents.
Yeah, that's new. In this sample, it wasn't the case. Yeah.
And the second, intelligence is not a perfect predictor for success in school. If you add to an intelligence test, for example, the educational level of parents, it could be that you improve the predictability of school success, but it would not be a criterion of the child itself. It would be somewhat unfair, but you can increase and explain variance. And the final comment, I also suggest that we use central tests, student achievement tests, to make the decision who is going to a gymnasium or not. But I think it's in Germany totally impossible to make this, because then many people or parents could not decide that their child will go to a gymnasium. Especially if you have the problem with parents with academic background.
I agree that in the recent years it's the parents' decision, which makes it even worse, because the social bias increased after this, because low-educated parents do not dare to recommend their child for the gymnasium. But of course you agree we couldn't just add, or we couldn't add for the decision the social background of the parents. And if it really increases the achievement outcome, this is a very bad sign for schools, because schools should compensate for children's background. That's the purpose of schools. So if a child is really intelligent, no matter what background he or she comes from, she should learn proper reading and all these things in schools if we would have good instruction.
Last question. Excellent talk, and I imagine it went down reasonably well in this audience, the idea of holding two concepts in your head, education and intelligence at the same time. It's really good. I wonder if you could give us your intuition about why. My intuition is that would go down less well in an education conference. And I don't understand why. I don't know if you do.
Probably you have. Probably you should go to educational conferences, for instance, for the European Association for Learning and Instruction. Some of you may be a little bit biased when it comes to educational psychology, that they are not interested or they even deny intelligence. I think this has really changed tremendously in the last years. And I published all these papers in the Journal of Educational Psychology, of course, which is a high-ranked journal. They accept individual differences. Probably there are some teacher education institutions which do not want to accept it. Therefore, I think it's very important that teacher education takes place at universities so that research and scientific findings can be taken into consideration when it comes to planning the curriculum.
Okay.
Yeah, thank you. In an hour we meet at the Landhauskeller. Please take your name badges. They are the ticket to having the bank, taking part in the bank. See you later.